So our next presentation will be, sorry, can you see my screen or it's gone? Okay. Will be about climate risk, about the climate change index that the Singapore Actuarial Society is doing. This is a very dear topic that is coming up, and we've been in successive progressive discussions in the recent months. We are on the verge of applying the Actuaries Climate Index, the ACI index, as Davy DAO will then mention. This index is very important because, as I mentioned earlier in my introduction speech, we are looking at least starting something from the actual point of view and contributing to the climate risk debate. So the modeling and the data and the parameterization of this index is what Davy DAO will be covering. Basically, the motivation for this index is, as what we've discussed with the International Actuarial Association. We are looking at we have already started with some discussions, and collectively with the global effort, we are looking at the formulation and how to adapt Singapore-specific parameters in the index. For instance, rising sea levels, precipitation, and temperature have to be specific to Singapore. So with Davy DAO, we will use selected methodologies and using R and automation techniques to bring this forward. Let me. Yeah.
Do you want me to present all the slides?
Yes. Present your slide first. Let me introduce you. Okay, so Davy DAO is a senior consultant in the actuarial and insurance team with Deloitte. He has 5 years experience. He has previously worked with Deloitte France, and now he's in Singapore. Recently, he has been working with Deloitte New Zealand, where he was involved in the development of the actual climate index in New Zealand. So, okay, so on my side, I am liaising with the Climate Risk Task Force with the International Actuarial Association, and as I mentioned earlier, this is one of the issues, one of the projects that we're working on. Okay, so without further ado, I'll hand over to Davy, and he will give a run through on the methodology and the approach that we are taking, and also talk about the precipitation work, the basically is rainfall and what we're going to show at least on this dimension. Okay, Davy DAO, over to you.
Yeah, just tell me if you can see the screen and the slides.
Yes, it's good.
Thanks, Paul, for introducing me to everyone. I'm conscious that it's just before lunchtime, so I'll try to make sure that we're on time because lunch is important. But I will talk about the SCS Actual Climate Index. So it's more like, what is the climate index? And so it's studied in the United States, so we'll come back to it after. And then how can you make it specific to Singapore? So these are like the 2 parts of the presentation. So we'll start with this quote from Barack Obama. There is one issue that will define the contours of the century more dramatically than any other, and that is the urgent threat of a changing climate. So I really insist on the word urgent because insurance industry is not the, is not the most famous industry to be the quickest to change. It's quite a slow change industry. And fortunately or unfortunately, actuaries, we are part of this industry. And we need to deal with all this risk. Climate risk at the moment is not the most important one. It's just like a stepped risk. But if climate risk becomes the new normal, then we'll have to factor all this new risk in our daily practice for the pricing. And it's really important because climate change will have tremendous impacts on the underlying itself of the industry. And to use pricing model, you need data. So it's just not about accuracy, like having enough data, accurate data, it's also understanding them. And we are actuaries, we are not climate scientists. And so we need to be humble and say that we don't understand what is climate change, what is climate data, how the climate impacts the earth and stuff. So it's where we need help from climate scientists. And there were few projects around the world where you could see some synergy between climate scientists and actuaries. And one of them is the actual climate index. So what is the actual climate index? So I will refer to it as the ACI. So it started in November 2016 in the United States and Canada. So SOS, CAS, and the Canadian Institute. Then after 2 years, it was also developed in Australia. And like Paul mentioned, I was working in New Zealand. So Australia and New Zealand is like really close. So that's why we look at developing an index in New Zealand. And after I moved to Singapore, so hence I talked to Fred, the president, and Paul. So we had the idea of creating this index for Singapore. So what is the purpose of these two indices? It is to be able to provide an objective indicator of the frequency of extreme weather, extreme events, and also sea level change. And it's a tool to be able to talk with actuaries, policy decision makers, and the general public to raise awareness about climate change. To answer simple questions like, is it raining more than normal or less than normal in Singapore? Because like when I arrived here, everyone was telling me, Dave, it's raining a lot in September, more than normal, but it's based on intuition. And so using this index, we will be able to answer with data and say, yes, it's raining more than usual. So let's take the example of New York in the United States. How can we answer to the question, is it raining more or less in New York? And so first, how do you define more than normal? So normal refers to a reference period. So in climate science, usually it's 30 years. So in this index, they were using 1961 to 1990. So that's the orange line. And so it means you have 30 years of data. It means for each month, you have 30 values, and you can derive a mean and a standard deviation for precipitation. So you will have 12 reference values, 12 means, and 12 standard deviations. These are the reference values. And after over time, like from 1992 to now, you will just track and compare to this reference value. So you just like take October 2020. There was like X amount of rain during that month. You will subtract the reference value, the mean, then you will divide by the standard deviation. So it will give you by how many standard deviation you're above or below the mean. So it gives you a non-unitized value to give you an indication on how is it changing, like is it raining more or less. So if it's above 0, it means it's raining more than normal. If it's below 0, it means it's raining less than normal. So this is the graph on the right. So on the left is like all the monthly reference values. And on the right, these are the anomalies that I'm talking about, above or below the standard deviation, above or below the mean. And then there is a 5 years smoothing mechanism, because you don't want like the outlier just like to just change the graph too quickly. So that's why if there's like a trend, then you cannot like, it needs to build up to be able to identify the trend. So it's how it works for New York and on this example of precipitation. And so this index includes more components. So it's just not about precipitation. So there's also the temperature. So it's the frequency of temperature above the 90th percentile and below the 10th percentile. You have the precipitation, so what I was mentioning. So it's the maximum 5-day precipitation. So it means during that month, over a time period of 5 days, you take the maximum amount of rain. Then you have sea level. So the standardized changes in sea level, high winds, and drought. So these are the 5 components of the climate index in the United States and Canada. And then how do you combine all of them? So because they're standardized, so they don't have any units, so you just can take the average of these components. It's how you can see on the right side. These are the final climate index using all the components and just taking the average. So the reference period, like I mentioned, is over the reference period of 1961 and 1990. And so you can see over time that that's kind of like the proof that in the United States and Canada, that extreme events became more and more frequent over time with this graph. So that's for the United States and Canada. But after, how can we develop the same for Singapore? So this is the kind of like the roadmap that we're following. So you need data first. So we use the MSS database, which is the National Weather Agency. And so we use an R script to just like pull out all the data for different weather stations over a different time period. But this is just the raw data. So after you need to transfer them because sometimes they replace weather stations. So you need to retrieve the data. And then there's no weather station across the whole country. So we need to understand the data with the expertise of climate scientists, how to choose the right ones to be able to make sure that we're using the right data sets and right data period and reference period. Then the modeling. So this is what usually we're quite good at. So there is a document which is called the Development and Design ACI document that we use. And so there are some guidelines. This code is not public. Our code will be public. And how can we make sure that we are implementing the right thing? So we implemented the model for precipitation. The other components still need to be developed, but we have the precipitation. So what I ask the people working for me, I just say, well, we can try to use the New York City data, like the example that I showed you. So we did it, and we got exactly the same output. So it gave us confidence that the model was appropriate. And then after there will be some visualization. So our goal is to using R or something different. This is not finalized, but our aim is to embed so that the index will be embedded in the SAS website so that you'll be able to like track the indexes for the different components for different weather station or the whole country on the website. And there's one step which is missing on this roadmap is interpreting the results, because I think the message that we can give with these numbers is the most important. And like I mentioned, it's where we need to really work with some climate scientists to be able to explain why is it changing or not. So on the next slide is the result for Changi Airport for precipitation. So it's on the left, it's kind of like the reference value. So we use a reference period of 1981 and 2010. Why? Because this is the earliest data set that we could find. And you can see on the right, these are the anomalies. And so, like I told you, we are not experts, so I can't interpret the results, and I can't say why. So I went to meet a climate scientist. His name is Dr. Benjamin Horton. He's the Earth Observatory Director. So we had a good chat, and I showed him this graph, and he asked me, "What do you think?" And I said, "I don't think there is any trend. It's just like moving up and down around zero, but there is no clear evidence of like climate change." And he said, "I agree." But he told me, you need to be careful around how to use the data, because how you choose the reference period, how you choose the measure is quite important. And so for example, he told me to look more into the past, like from the 1900, so like in 1900, to check if there was a trend, like a long-term trend, because this is quite recent. And it's where we need to be able to talk with some climate scientists to be able to interpret the results. So I was just wanted to show you this graph because it's kind of like just a source of discussion with everyone. And not everything is finalized. So like reference pair can change, the variables can change. It's just an example to show you what we can do in a short time frame and what we like to do after. And so we did a sensitivity around the measure, because most climate scientists talk about total monthly rainfall, so like how much it was raining during that month, and just for every day. But insurance, we are more looking into extreme events. So even if it's raining not a lot, but every day, it won't have any impact on insurance industry. While if it rains a lot during a 5-day period, then it's where you can have some consequences. So we were just looking at how it could be different. And you can see that the graph is not different, but the peaks are different, which means over a long-term period, you could think that it will change the speed of climate change. So that's where we need to be careful how to choose the right variable for Singapore, and because Singapore is specific, which leads to the 4 key points for the SS actual climate index that we need to be aware of. So choosing the right variables is key and essential, because the index was first developed in the United States and Canada, but it's different because they have 4 seasons like summer, winter, fall, and spring. But Singapore, there is only 2 seasons-ish, like monsoon or non-monsoon. So it's quite different. So there are some variables which could be relevant to Singapore. For example, humidity. It's not that it's quite hot in Singapore, like everyone knows. It's more like it's very humid. And it's one thing that we could look at. And when I was talking to Benjamin, he said that wind is not a dominant risk in Singapore. There's no like cyclones in Singapore. So it's where we need to be able to use what has been done, but also make it specific to Singapore. And the second point is data availability and reference pair. Singapore, for different reasons, doesn't have a huge amount of data. Most of the weather stations only go back to 1980, while, for example, in Europe or the United States, it goes back before 1900, which is quite a lot of data set. And what I was mentioning to you, choosing the right reference pair is so key, because usually when people nowadays say, oh, it's running more than usual, they only look at the last decade. And it's true, for example, if you I look at the data, and if you look at the last decade, in June, September, it was raining a lot. It was the highest amount of rain for the last decade. But if you compare to 1980 to 2010, it wasn't raining more. So it's where we need to be careful. And we were looking at Chengdu Airport, but there are different weather stations across the country, and some were replaced. And so when I was talking to Benjamin, he was really enthusiastic about this index, and he was like, we need to look at the spatial variability, because urbanization have a huge impact on climate, like because the buildings can absorb heat and reflect heat. Then, for example, for temperature, you will have different measures and different temperature across the island. And it's where we need to be able to look at the climate index for per region for the whole country. And it's what we would like to do after. And the 4th key point, which is probably the most important one, is interpret the results. And there is a big difference between climate variability and climate change, because there are some cycles also in climate science. And one of them is the El Nino Southern Oscillation. So what is it? Just to give you a brief summary, it's the Pacific Oceans, the temperature at the surface, which have an impact on the rainfall. And it's like a cycle. It can take 3 to 5 years to like have different impacts. So sometimes it rains more, sometimes it rains less. And so there is some variability in the climate change. So we need to be able to explain if there is a trend, if it's due to human activity, which is climate change, or if it's just due to natural causes. So it's why you need to remember for these 4 key points. And I would like to quote Jim Yong Kim, who was the former president of the World Bank on climate change. He said, we have to wake up to the fierce urgency of the now. And I like the word now, because I think insurers right now, they don't think about climate change as an immediate risk, which is probably fair or not. It's more all around the world. If you ask climate scientists, when I was working in New Zealand and when I was working in Singapore, when I was asking people, is it happening soon? And they were all like, yes. People underestimate the impact and the speed that climate change will have on everything. And it's where we have to be able to work all together, not in silo, because it will have huge impact on the insurance industry. And it's more like humans like to build houses next to the coast to have a beautiful view. But if this house disappears, because of coastal erosion, because of sea level rise, then banks will lose a lot of money because of the mortgage. But insurance industry will be impacted too, because how can you insure a house that you know will disappear? By definition, insurance event need to be random. But if it's not random anymore, you can't insure anymore. And if the underlying disappears, the reinsurance industry will also be impacted. So that's why people underestimate the impact of climate change. It will happen sooner than people think. And so just to summarize, it's still early stage. So just to give you some key points of what we are trying to achieve and where we can go. So everything needs to be finalized, like data, which data set we need to use, which key variables we need to use, to be able to make it relevant and specific to Singapore. And it's where we need to involve a lot of people from all different areas, climate scientists, actuaries, regulators. So it's more like to put everyone at the table to talk. And it's kind of like this climate index is the first step to be able to talk, rather than having nothing and just say, oh, it's raining more than usual. Then having this index would be a huge milestone to be able to talk to people and raise awareness. And when this index will be finalized, some possibilities to extend further will be to extend to other countries in Southeast Asia, to include projections, because this climate index only look at the past at the moment. And then ultimately, it will be like, if you have projection of this key component, how can you translate financially the climate change impact? And that's the ultimate. Thanks for listening to me. I think I'm on
Thank
time.
you. Thank you, Davy, for the very exciting and practical presentation on the implementation of climate index. And it brings us definitely a lot closer to reality now, as actuaries, and also our involvement in the climate risk challenge. So we have two questions. Davy, I'll read out both to you, and then we can address them concurrently, separately. So the first one I got from the chat box is it's about standardization. It's about the selection of the variables and the methods. How do you choose the different variables, and what statistical methods are used? And how many variables do we have at the beginning, and why do we decide or select certain variables? I think this is in line with the methodology of the ACI. You can see the second question is, do you think that the weather measures would or should be consistent for all countries in Southeast Asia, or would they vary? Okay, so yeah, so with these two questions in mind, yeah, your response.
Yeah, so I will answer first to the first one. So how were these variables were chosen? So the goal was to choose some variables to reflect the most impactful for United States and America on climate change and the economy. And so it's where they were using more like extreme events measures. So like what I was mentioning, high winds, frequency above the 90th percentile. So it's more like there was a consortium of climate scientists. So the United States just came to a climate science consulting firm and say, what do you think we should use to be able to make it more relevant to Singapore? And so they came up with the temperature, high winds, because there are like a lot of cyclones. Temperature is kind of like normal. Precipitation, but also drought, because if you look at rainfall, then you need to have the two sides, like if it's raining a lot, or if it's not raining at all. So precipitation and drought. And sea level is, I think, one of the most obvious one. So this is for United States of America. Then for Australia, they use the same. So they exactly use the same variables. But for Singapore, how would you choose our variables is what I was saying. Some would be not relevant, for example, high winds, because we are not at the same latitude or longitude. We are like at the equator. So these are different impact on climate change. And the first one, which would come to my mind, would be to use relative humidity, because it will have a huge impact. It's not that temperature, like hot temperature, is not important, but it's more like if it's really humid, then you can't sweat. And then if you can't sweat, then it's where you can have like heat stroke and stuff. So it's more like it would be more impactful in Singapore to use humidity as a component rather than high winds, for example. So it's more like by talking with climate scientists that we can define the variables. And then after, for the 90th percentile and 10th percentile is something which is also debate that we need to talk, I think, in the industry. How would you define extreme? So it's kind of like subjective. And so it's more like we won't decide right now. It's more like by bringing everyone at the table is what we can discuss. And the second question was, do you think we should use the same for all the different countries in Southeast Asia? That's a tough question. I would say I don't know the answer because it's more like how the climate impacts is different all around Southeast Asia. For example, sea level, it's not really impactful for Singapore, from what Benjamin Houghton was telling me, but it's more like in the country for Philippines and Indonesia, where it's quite impactful. So rather than just using the average, then you could put more weight on some components. So still you can still debate on which one to choose, but it's something that we should just choose by ourselves. It's like we really need to involve climate scientists in these decisions. That would be my answer.
Thanks, Davy. Which also links a little bit to what I'm thinking, and also there's a new question. The question actually is, how had the climate index in North America and Australia been used to calibrate risk exposure and financial impact on banks and insurance companies? Okay, so bridging these two questions, okay, I want to ask you, Davy, to what extent when we create all these indexes globally and for Singapore as well, do you think that we should balance the need to be consistent in terms of components and calibration methodologies, okay, consistency across, say, America, Europe, and Singapore, okay, versus the need to reflect regional or country-specific characteristics, like temperature is different in Australia and in Singapore, right? The range. So, any views on this?
We can do both, but I think it should be specific because, like, let's say you take the example of the graph on the right. This gives a message per season. So the season is like winter, summer, spring, and which one? Or fall.
4 seasons.
So it will give you an index per season. But if you plug just the same for Singapore, there is no summer. So it will give you a very different message. So I don't think it should be consistent across the whole world because the world is not consistent. There is different climate everywhere, all around the world. So I don't think it should be relevant and specific to Singapore because if you have numbers, then what would you say about this graph? If you have a winter graph, there is no winter in Singapore. So it would be quite dangerous to just try to use exactly what have been done. That would be my answer.
So in other words, we should use the same 4 components as globally, but we will adjust to reflect the specifics of Singapore, right? Not introduce new components as well. Maybe as a different, maybe humidity, right? For instance, okay.
We could.
Yeah, we could. Okay, we can discuss this later. Yeah. Okay, so on the third question, maybe on answer as well. Actually, it's a broader application of the index. When they calibrate risk exposures and financial impacts. I think this it links to the discussion on stress testing, right, Davy? So, index can be a historical guide, okay, and also maybe it's just like inflation. Long time ago, inflation is discussed, and now we use it in our pricing as if onlining for general insurers, okay, to readjust inflation adjustments. Do you think the index will one day be something like a climate index that's used to adjust exposures?
Yeah, that would be the ultimate goal. So to answer the question, it's still early. So this tool is more like to look at the past and just say, oh, it's extreme events that become more frequent, but there's no financial or risk exposure yet. It's too early. It's like too early stage. And to answer the SCRI, which is the actual climate risk index, which is a new index by the SOICAS about risk, which is more like the impact on economy. That's something that we could look at. It's kind of like implicitly in the financial impact of climate change. That will be one of the goals. But first is where I insist, we need to finish first this index before like trying to do more and more stuff. It's more like to finalize first what we can do. make it relevant and make it specific to Singapore. Then after we can expand to new countries, new variables, financial impact. But first, finish this one.
So just a quick comment to Davy as well and to everyone. So Davy, can you mentioned before the source of data for the production of the Singapore index is all public, right? Insofar as Singapore is concerned. So it's a matter of, can you elaborate more on where we've got all the data from so far?
Yeah, so basically it's like when you look at the weather, like the NEA website to give you data. So they have weather station across the whole country and they just record everything for all the components and except sea level, but you can get all the information from the 1980. But when I was talking with climate scientists, 1980 usually is not enough to identify long-term trends, especially in climate science. So there's only one station, which is McRitchie, which goes back to 1879. So as we are still pending, so we're talking to MSS to get this database for McRitchie for rainfall, just to be able to see how it looks like if we were choosing a different reference period. But actually, but at the moment, the MSS database is quite a good source from 1980.
Okay, maybe just elaborate a little bit on the operational resources and work that we need to do, because currently we have a sort of an internship kind of arrangements, right? We need to get more people, but generally speaking, the work is not that intensive, right? It's R based, and we have done the precipitation bit, right? We can maybe elaborate on from your point of view, how much commitment is needed so far that we're budgeting.
It's hard to say. So we would like to finish in 2021. Okay. So it's intensive, yes and no. It's more like the modeling is not that hard, that's correct, because like we usually work quite good at modeling and there is already something done and we have finished for precipitation. So as long as you have the structure, the framework, it's not really hard to replicate for every component. So like precipitation, it's a model. So like you subtract the mean, you divide by the standard deviation, and then you can do for the same for sea level. It just you need to plug different data, like just the sea level data, but the model itself will be the same. And so we have someone helping to code for the R modeling. So I'm reviewing more or less. So I'm more like involved in interpreting the results. So I'm like, does it make sense or not? By just like validating against like previous data from the United States. And then I'm also in charge to find the data. So that's and interpret the results. So it's where I'm like liaising with different people to try to understand and present to them, and if they are on board. And so that's why Benjamin would be happy to help us to understand the data and interpret the results. So it's how it's the resource. And so there's also an intern helping us with the SAS on the visualization part. So it's what I was mentioning, that we would like the index to be embedded on the website. So it's more like visualization. So like you would be able like to have some maps and find the climate index for different
real
components.
time. Yep. Yeah. Very good. Very good. So this is a good step to bring this forward. So we have quite a lot of good questions that have been coming in just now. So if anyone also has further questions or comments, please feel free to put them on the Q&A box or in the chat box. Yeah. So Davy, thanks. So Davy, just some discussion points as well. Do you? Yeah. So in terms of the applications of the index, any ideas and comments on the further work streams that we should be doing to link the application of this index, as one of the earlier questions has said, in terms of how it can be used to calibrate risk exposures and used in the broader insurance and financial services sector.
So it's so the first application will be to raise awareness and talk to regulators, because there is regulators at the moment with some there's like a whole international kind of like movement towards disclosures around climate change. So that's why it's kind of like happening around the world. So one of the key points, like to be able to talk with regulators. And I think actuaries should be involved in this type of discussion. The second point would be, because it's only looking at the past, to add some projection, like how can the sea level rise evolve in the future? And this is kind of like linked to the different scenarios, like what that you can mention, like at the different organizations, like I forgot in English, it's the UN, for example. So they are talking about different scenario, like if you don't do the Paris Agreement, then it can change by X degrees, etc. So this can give you some indication of the projections. And ultimately, when you have these projections, then it's where you need to talk to climate scientists, how it can impact the Earth and how it can change, how can it impact the assets, how can the sea level change the cost, and after it's where actuaries can translate this into a financial risk, because you'll be able to calibrate your model, like if it's the sea level rise by X amount, then this house will disappear. So that's the amount of money that you can lose. So it's where I think you can other possibilities for this index.
Exactly, Davy. So we should approach this in a building block approach, whereby we get the pieces together, the foundations of our contribution to climate risk. The climate risk index is one key part concerning the data. The awareness is another part, and also the tools and methodologies. And then with these building blocks in place, we'll slowly be able to put the pieces in and build the foundation for creating stress testing and including the pathways and representative the RCPs, the relevant RCPs at the high, medium, low range, and so on and so forth, and then to estimate the impact on the financial exposures and so forth. Yeah, right. Yeah. Okay. Yeah. Okay, we're coming to the end of this presentation. No further questions are seen. Oh, there's another one. Okay, maybe just take the last question. So Davy, are you able to share any preliminary insights into how the climate has changed for Singapore based on the the calculation of this ACI? Yeah.
It's too early because the component we implemented for this conference was the precipitation, but only for Shanghai, and it's where I was showing you the graph. There is no clear trend at the moment. So it was like fairly flat because it's just variable. It's like just up and down. It's only looking at right now. But from the insight that I got from Benjamin, if you go further in the past, like from the 1900, you will see that it has increased by quite a lot. It has increased by quite a lot. And there's also like a downward trend between the 1950s and 1970s. So this one is because of just variability. This way it's important to interpret the result correctly because the message can be different.
Exactly. So there is some data related preliminary insights, and we should look to supplement this with interactions with the climate scientists, as you say, right? Yeah. Okay.
Correct.
Yeah. Okay.
So if anyone is interested, like to join the project, that's also like, don't feel free to ping me, and like it's quite an interesting project. And if you have any more questions, you can just ask Paul to have my email, and I will be glad to answer to any questions.
Yep. Yeah, indeed. So we are looking any volunteers and people who are interested in research students or people who are interested to help on the actual programming part as well. Yeah, we will definitely take it on as well. So this comes to the end. Thank you very much, Davy, and it's time for lunch. The next one will be at 1:30. Okay, on epidemic risk modeling. Okay, Davy, thank you very much for the time and excellent and very practical presentation on climate risk. Thank you. Thank you,
Thanks.
everyone.
Bon appetit. Bon appetit
Thank
to
you.
everyone.
Thank you.
Bye.
Bye.